Hello friends, welcome to xiii. In this video, we shall be solving questions of exercise 5.1 on arithmetic progressions. So let's start. Now talking about question number 1, which says, in which of the following situations does the list of numbers involved make an arithmetic progression and why? So talking about the first question, first sub part, it says the taxi fare after each kilometer when the fare is 15 rupees for the first kilometer and rupees 8 for each or every additional kilometer. So now the taxi, we are talking about question number 1 and we are talking about the first sub part. So it says the taxi fare is basically fixed plus the variable part. Now what is the fixed part here? The fixed part is rupees 15 and thereafter the variable part is rupees 8 for every kilometer. Rupees 8, and this is the fixed part for the first kilometer. And after the first kilometer it is rupees 8 for every kilometer. So can I put it like this? Now here the first term, which is the first kilometer, is rupees 15 and then for every kilometer after this it is rupees 8, right? So can I form an arithmetic series here? Yes, I can say the nth term here will be what? A plus n minus 1 into d. And what is the value of a plus n minus 1 into d? So here we will get what? 15 plus, do we have for how many kilometers? So n here stands for the number of kilometers, the total number of kilometers. For example, this was the first kilometer. So if I have to write down the AP, it will be 15 followed by 23 followed by 31 and so on. This is the arithmetic series that is formed. So which eventually we can say the arithmetic series that is formed here is 7n, sorry, this will be 8n plus 7. Now if you want to check where n stands for the number of kilometers, so for the first kilometer you will have what? 8 plus 7 rupees, which is 15 rupees. For the second kilometer, I mean after 2 kilometers, the cost will be 8 into 2, 16 plus 7, which is 23. After 3 kilometers, the cost should come out to be 3 into 8, which is 24 plus 7, which is 31. So the question says, is this an AP? Is this an arithmetic series? Yes, it is, and why? I have already explained it to you. So yes, it is an arithmetic series. Talking about subpart 2. Now when I talk about subpart 2, it says the amount of air present in the cylinder when a vacuum pump removes 1/4 of the air in the cylinder at a time. Now this is an action which is a one-time action. So it starts and then it stops. Now what does it stop? You will just say, initially if I say that the volume of the cylinder was V, I mean let's say the volume of air present in the cylinder, let's say initially, so let's put A as V, the first term. Now for the second term, now when it was V, now the pump removes 1/4 of the air, it removes 1/4 of the air remaining in the cylinder. I'll repeat the sentence. The amount of air present in the cylinder when a vacuum pump removes 1/4 of the air remaining in the cylinder at a time. So this doesn't form any series because it starts and it removes 1/4 of the remaining air. So it keeps on removing, let's say, and it does not even say at what step does it stop. Does it stop after 1 step or does it stop after 2 steps? It doesn't talk about any step. And arithmetic series should have how many terms at least? If I were to answer this question, in order to ascertain what kind of a series is it, you need to have at least 3 terms like we had here. So in order to ascertain which kind of a series is it, I mean it has to be either an arithmetic series or a non-arithmetic series. So all other series, we'll put it under the head of non-arithmetic series. For that also, you need to have first 3 terms, which is missing here. So you cannot even ascertain whether it is a series. So is this? No. Is this? Yes. And which kind of a series was the first one? It is an arithmetic series. So I'll put it as A dot S dot. Talking about question number 3. So subpart 3. It says the cost of digging a well after every meter of digging, when it costs rupees 150 for the first meter and then rises by 50 rupees for every subsequent meter. So let's say the first meter, second meter, third meter. Now what we are saying here is, let us say after 1 meter, after 2 meters, after 3 meters, after. So let's say here, now the first term after 1 meter. So the first meter, what is the cost? Rupees 150. For the second meter, what is the cost? It increases by 50 rupees after every meter. So now the difference here will be how much? 50 rupees. So this becomes 200 rupees. Next, this becomes 300 rupees. 250 rupees. Next, it will keep on increasing by 50 rupees. So do you have at least 3 terms? Yes. Do you have a common difference between these 3 terms? Yes. So is it an arithmetic series? Yes. So yes, it is an arithmetic series is what you are going to write. Subpart 4. Now subpart 4 talks about the amount of money in the account every year when rupees 10,000 is deposited at compound interest at 8% per annum. Okay, so do we know the formula for compound interest? We do. What is the amount due after n years? The amount due after n years is nothing but, or let's say the amount due after t years will be the principal amount times of 1 plus r by 100 if the amount was increasing every year. Otherwise, it becomes 1 minus r by 100. Here the amount increases every year at the rate of 8%. So now if I have to find out the amount after 1 year, so I am having what here? I am having a power. So you will say that the amount after 1 year will be nothing but p times of 1 plus r by 100 to the power 1. Without even substituting values, you can ascertain what we are going to ascertain in next few minutes. So now when I find out the difference between these 2 terms, let us say this is the third term. Now if this had to be an arithmetic series, A3 minus A2 should have been equal to A2 minus A1, which does not happen in this case, which is why it is not an arithmetic series. So which kind of a series is it? If I were to tell you, as of now, you can just say it is non-arithmetic series, but to be more specific here, it is a geometric series because it has the same ratio. What is the ratio here? The ratio is, if you multiply the first amount with 1 plus r by 100, you get, if you multiply this amount with 1 plus r by 100, you get p times of 1 plus r by 100 whole square. Now when you multiply this amount with 1 plus r by 100, you get it as the amount after 3 years is p times of 1 plus r by 100 whole cube. So there is a common ratio, and the word common ratio is not used for an arithmetic series. It is used for a geometric series. So which is why this is not an arithmetic series and it is a geometric series. As of now, you will not call it as a geometric series because you have not been taught. So in that case, you will call it as a non-arithmetic series. No, it is not an arithmetic series. Right? Let's move on to the next question, which is question number 2. So question number 2 says, write first 4 terms of an AP when the first term A and the common difference D are given as follows. First 4 terms. So talking about subpart 1, it says A is equal to 10 and D is equal to 10. Okay, and I'm supposed to write down the first 10 terms. Okay, I'll write down I'm supposed to write down the first 4 terms. Now I know that the first term is A, the second term is A plus D, the third term is A plus 2D, and the fourth term is A plus 3D. So the first term is a, which is 10. So 10 plus 10, 20. Another you add 10, 30. Another you add 10. Because you are saying what? Basically you're going on adding d to all the terms. These are the first 4 terms. Talking about question number 2. What is the value of a and what is the value of d? Let us find it out. So the value of a is -2 and d is 0. So in this case, as discussed earlier in my videos, all the terms would be equal. Any term, if you pick up from this series, would be the same as the first term. This is a very important thing to be understood. When the common difference is equal to a 0, whether the first term is positive or negative or 0, all the terms would remain the same. All. You pick up any term, that will be equal to the first term only. Okay. Now question 3rd, subpart 3. It talks about a is equal to 4 and d is equal to -3. So a is equal to 4 and d is equal to -3, which is just like saying the first term is 4, keep on subtracting 3. Keep on subtracting 3. You will never use a terminology like keep on subtracting -3, because if you subtract -3, it becomes +3. Or you can say keep on adding 3 to it, keep on adding -3 to it. These are the first 4 terms. Let us see. 4 minus 3, 1 minus 3, -2, -2 minus 3, -5. The next part. So it says a is equal to -1 and d is equal to half. A is equal to -1 and d is equal to half. So -1, again you add half to this. This becomes this. Keep on adding half. The next subpart. It says a is equal to -1.25. A is equal to -1.25. And what is the value of d from here? The value of d from here is -0.25. -0.25. Okay. So now -1.25. The next. So you keep on adding -0.25. So -1.25 becomes -1.5, -1.75 and -2 respectively, which is the last part. This was the last part itself. Okay, talking about question number 3. First subpart. So question number 3, first subpart, it says for the following arithmetic progressions, write down the first term and the common difference. So 3, 1, -1 and -3. Which is the first term here? And what is the common difference? So can I say the first term here is 3 and the common difference is nothing but the second term minus the first term. So when I do this, the second term minus the first term, we get it as -2. So the first term is 3 and the common difference is -2. In the second subpart, it says -5, -1, 3 and 7. -5, -1, 3 and 7. So what is the first term here? -5. And what is the value of d from here? -1 and minus of -5. So -1 minus of -5 makes it 5 minus 1, which is 4. And you can check your answer also. So keep on adding 4. So -5 plus 4, -1. -1 plus 4, 3. 3 plus 4, 7. Next subpart. So subpart 3. 1 by 3, 5 by 3. 1 by 3, 5 by 3. 9 by 3. And the next is 13 by 3. What is the first term here? 1 by 3. And what is the common difference? 4 by 3. How do you get 4 by 3? 5 by 3 minus 1 by 3. Next subpart. The next subpart says 0.6, 1.7, 0.6, 1.7, 2.8, 3.9. So what is the first term here? First term is 0.6. What is the common difference? Common difference is 1.7 minus 0.6, which is 1.1. Right? Let's talk about the next question, which is question number 4. And when I see question number 4, how many subparts does it have? It has 15 subparts. Okay, let's do them one by one. So talking about question number 4, it says, which of the following are APs if they form an AP? Find the common difference and write 3 more terms. Okay, which of the following are APs if they form an AP? Find the common difference and write 3 more terms. Okay, let's see the first question, and before we start, I have just written the formulas to be used, and this is something that you should understand for any question on arithmetic series. So for example, the nth term minus the first term is n minus 1 into d. This is nothing but the extension of this only. Any kth term and any rth term of the same arithmetic series has to be understood as k minus r into d. Second term minus the first term is d. These are some formulas that I have written for ready reference. Okay. So question number 1. 2, 4, 8, 16. First term is 2. What is the common difference here? The common difference should be 4 minus 2 should be the same as 8 minus 4 should be the same as 16 minus 8. Now 4 minus 2 is 2, but it is not equal to 8 minus 4. So does it have a common difference? No. So is it an arithmetic series? No, it is not an arithmetic series. Let's see question number 2 or subpart 2. Now the subpart 2 is 2, 5 by 2, 3, 2, 5 by 2, 3, next is 7 by 2. The very first thing that you need to check here is, let's see the common difference. So the common difference should be 5 by 2 minus 2, which should be the same as 3 minus 5 by 2, which should be the same as 7 by 2 minus 3. So now in this case, this is 2.5 minus 2 is 0.5, 3 minus 2.5 is 0.5, and 3.5 minus 3 is 0.5. So they have a fixed common difference. And what is the common difference here? 0.5. Is it an arithmetic series? Yes. Now the point is, write down the next 3 terms. So the next 3 terms, let me write down the series once again. 2, 5 by 2, 3, 7 by 2, you add 0.5 again, this becomes 4. Then 4.5, which is 9 by 2. And next 4.5 plus 5 is, 4.5 plus 0.5 is 5. So I've written all the terms. Next, subpart 3. Now subpart 3 says minus 1.2, minus 3.2, minus 1.2, minus 3.2, minus 5.2, and minus 7.2 is what the question is. Right? So how much can I say if I keep on adding minus 2? What is the common difference? The common difference here I am saying is minus 2. How? Add minus 2 to 1.2, you get 3.2. Add minus 2 to this, you get 5.2. Add minus 2 to this, you get 7.2. So let me rewrite the series, the next 3 terms of the same series. So the next 3 terms would be minus 9.2, minus 11.2, and minus 13.2. You just keep on adding minus 2. Subpart 4. Okay. Subpart 4 says minus 10, minus 6, minus 2 and 2. Minus 10, minus 6, minus 2, plus 2. So if I keep on adding 4, so for example, if I add 4 to minus 10, I get minus 6. I add 4 again, I get minus 2. I add 4 again, I get plus 2. So the common difference here is 4. Okay, I had to write yes here. Yes, it is an arithmetic series. What are the answers that we have got till now? So I'm using a cross. No, it is not. Second, yes. Third, yes. Fourth, yes. But we are yet to write down the next. So if I have to write down the next 3 terms, I'll be writing it as 6, 10 and 14 are the next 3 terms. Okay, next part, which is subpart 5. Now the subpart 5 says 3 plus root 2. Okay, 3, next is 3 plus root 2, next is 3 plus 2 root 2, next 3 plus 3 root 2. Okay, now in order to find out the common difference, this minus this gives me root 2, this minus this gives me root 2, and this minus this. So we are talking about the second term minus the first term gives me root 2, The third term minus the second term gives me root 2 again, and the fourth term minus the third term gives me root 2 again. So it should be arithmetic series. Let me write down the next three terms. So 3 plus 4 root 2, followed by 3 plus 5 root 2, followed by 3 plus 6 root 2. And the answer is yes, it is an arithmetic series. Subpart 6. So subpart 6 says 0 minus 4 minus 8, 0 minus 4 minus 8 minus 12. So here the first term is 0 and the common difference appears to be minus 4. Why? Because we are keeping on adding minus 4. So is it an arithmetic series? Yes. Yes, it is an arithmetic series. What are the next three terms? Minus 16, minus 20 and minus 24. Moving on with the next, which is subpart 7. Okay, subpart 7 says minus 1 by 2, minus 1 by 2, minus 1 by 2, minus 1 by 2. So few minutes back only, or if you have seen my videos on the basics and various concepts, you know that in an arithmetic series, all the terms can be equal to a 0, or the first term can be a non-zero term, but the common difference can be a 0. Okay, so here the first term is a non-zero term, which is minus 1 by 2, and what is the common difference here? 0. So now in this case, as discussed earlier also in one of the question, now all the terms will be equal to minus 1 by 2 only. So the next three terms will also be minus 1 by 2 each. Talking about question number 8, which is subpart 8. Okay, now subpart 8 says okay, we missed on one question. So this was not the seventh one. We missed out one question here, and instead of the sixth one, now the sixth one was a different one. So what I'll do here is, this we have discussed. This is question number 7. This is question number 8, and now I'll talk about question number 6. This happens, I hope you would not mind it. So question number 6 is 0.2. We are talking about subpart 6. 0.2 followed by 0.22, followed by 0.222, followed by 0.2222. Now the moment you see this, you will say that the first term is 0.2. What is the common difference? Now here the common difference would be 0.02. So you will say what? This is 0.22 minus 0.2. So this becomes 0.02, but the moment you subtract the second from the third, so this is just like saying 0.002, and then you will say 0.0002. So the common difference is not the same. So now let me put a tick mark here. Yes. Is this? Yes. Arithmetic series. Question number 8. Yes. Question number 6. No. It is not an arithmetic series. Let's talk about subpart 9. So subpart 9 says 1, 3, 9, 27. 1, 3, 9 and 27. So the first term is 1. Now, do you have a common difference here? So 3 minus 1 is 2. Then 9 minus 3 is 6. 27 minus 9 is 27 minus 9 is 18. So you do not have a common difference here. No, it is not an arithmetic series. No, it is not. Subpart 10th. Subpart 10th is a, 2a, 3a, 4a. So what is the common difference here? The common difference here is a. You add a to a, 2a, 2a plus a, 3a, 3a plus a, 4a. So you have a common difference. Common difference means yes, it is an arithmetic series. Subpart 11. Subpart 11 talks about a square, a cube. A square, a cube, a to the power 4. The first term is a. What is the common difference? You don't have a common difference here, because a square minus a is not equal to a cube minus a square. Let's check it out. So when we are saying a square minus a, this can be written as a times of a minus 1. Now the moment you say a cube minus a square, this is just like saying a square times of a minus 1. So the common difference varies. It is not an arithmetic series because it doesn't have a common difference. Subpart 12. So when you talk about subpart 12, it is root 2, root 8, root 18, root 2, root 8, root 18, and the last one here is root 32. Okay, so the first term is root 2. Now how much is root 8 minus root 2? This itself is very difficult to find out, but is root 8 minus root 2 equal to root 18 minus root 8? You need to find this out. In order to find this out, this I can write it as, this is 2 into 2 into 2. So this can be written as 2 root 2. Now 2 root 2 minus root 2 is root 2. Okay. Now this root 2 should be equal to how much is root 18. So root 18 can be written as root of 3 into 3 into 2, which can be written as 3 root 2. And this we know is 2 root 2. So is it equal to root 2? Yes. The last thing that we need to check here is this equal to root 32 minus root 18? So this I can write it as, this is how much? 16 into 2. Now 16 under root is 4. So 4 under root 2 minus 3 under root 2. So they have a common difference. And what is the common difference here? What is the common difference? The common difference is root 2. Is this an arithmetic series? Yes, because it has a common difference equal to root 2. So talking about subpart 13. Now when we are talking about subpart 13, it says root 3, root 6, root 3, root 6, root 9 and root 12. Okay, before we go ahead, let me rewrite the terms. So this in any case root 6, this is 3, and this I can write it as 2 root 3. How much is root 6 minus root 3? Or can I say root 6 minus root 3 is equal to 3 minus root 6? Let's check it out. So root 6 minus root 3 is just like saying root 3 times of root 2 minus 1 and 3 minus root 6. Now if I take root 3 common here, I'll be able to write it as, so can I say that a2 minus a1, I mean here we'll be able to say that a2 minus a1 is not equal to a3 minus a2. So is it an arithmetic series? No, it is not. Subpart 14. So talking about subpart 14, it is 1 square, 1 square, 3 square, 5 square and 7 square. So how much is 3 square minus 1 square? Is it equal to 5 square minus 3 square? And is it equal to 7 square minus 5 square? So 3 square minus 1 square is just like saying 3 minus 1 into 3 plus 1, which is 8. Now this is 5 minus 3, which is 2 into 5 plus 3, which is 16. And this is 7 plus 5, which is 12. 12 into 2 is 24. They are not equal. So is it an arithmetic series? No, it is not. Last subpart, which is subpart 15. Okay, 1 square, 5 square, 1 square, 5 square, 7 square and 73 is what they have given. Okay, so how much is 5 square minus 1 square? 24. How much is 7 square minus 5 square? We just did it in the earlier one. This is 24. How much is 73 minus 7 square? Which is again 24. So do they have a common difference? Yes. Yes, it is an arithmetic series. Now, all the ways that we have discussed here are the ways that we have already discussed in our videos on the basics and thereafter the concepts and the basics on arithmetic progressions. And all these methods are these are the ways in which you will be getting a complete and the correct solution to the problems. Hope you will be able to take it forward from here. Thank you so much. Goodbye.